course, I would like to give you an overview about the course. So let us start. If I talk about the course overview, what things we are going to learn in this course? So the first thing that we are going to see is what is Web3.js. It is very important to understand that what is Web3.js. If without understanding Web3.js, if we directly switch to its modules and how the compilation is done, then it will be useless. So first of all, we will clear the base that what is Web3.js. And after that, we will talk about its modules with which we transfer Ether from one account to another account. We fetch accounts and all these things that Web3.js can do, all those things we will see here. We will see those modules which will help in doing all this. After that, we will talk about Web3.js and using it in a Chrome console. Now you must be wondering that what will happen if we use it in Chrome console. But don't worry, you will understand everything slowly and gradually. For now, we are just looking at the overview, and further ahead you will understand all these things in detail. After this, we will see that how to create ABI and bytecode using Web3.js. Till now, when we have generated ABI and bytecodes, we have done it through with the help of Remix IDE, with the help of Triffer. But how to generate ABI and bytecodes in our smart contract using Web3.js, that we will see here. After that, we will see our next step, that will be compilation. How will we compile our contract using Web3.js, that we will see. And with that, at the end, we will see that how to deploy our contract with the help of Web3.js. So in this course, all the information related to Web3.js from beginners to advanced that you will get. After this course, you will be very compatible in using Web3.js. If you are making a project and you want to use Web3.js, but whenever you see its documentation, you feel that it is very complex and you cannot understand anything, then all these problems will get resolved after this course. I will try to explain everything minutely and in detail so that it is easier for you to use Web3.js in your future projects. The next thing that we are going to talk about is Web3.js course prerequisites, which means what all things you should have idea about before starting this course of Web3.js. Okay, so the first course prerequisite is blockchain. So you should have a clear idea about blockchain and its basics should be very clear. You should have idea about Ethereum, how Ethereum works and all those things. With this, you should also have idea about Solidity. This is because we make smart contracts using Solidity and then we deploy it on our blockchain, that is Ethereum blockchain. And in this course, we will see that how we will compile our smart contract using Solidity and then how we will deploy it. So you should have a little idea about Solidity. That is the basic idea about Solidity you should know. And after that, you should have some idea about JavaScript. Obviously, you should have idea about basic JavaScript, but if you know something about advanced JavaScript, that will be better. Now, this course will be mainly focusing on Web3.js, but at certain places, especially while compiling and all that process, we will see the use of JavaScript. There mostly advanced JavaScript will be used, so you should have some idea about the JavaScripts also. Now let us talk about the software requirements. Softwares that you will need in your system before starting this course. So the first software that you will need is Node.js. You should have Node.js. With that you should have Ganache and you should also have VS Code. So you should know how to install these softwares onto your system, how to use these softwares before starting this course. So finally we are going to talk about Web3.js, that what is this Web3.js. So let us start with its definition. Web3.js is a collection of libraries that allow you to interact with a local or remote Ethereum node using HTTP, IPC or WebSocket. Did you understand it? If not, one thing that is important here to understand is that this is collection of libraries. So if somebody asks you what is Web3.js, then it is just a collection of libraries. And with the help of these libraries, you can interact with your Ethereum nodes. I will try to put it in a more simpler way that what Web3.js does. Now we have seen the definition and it is important to understand that how Web3.js works. So let's say that you have created a very beautiful website. This is a very good looking and a functional website. Everything was working fine and then it came to your mind, why don't I connect this website to my blockchain? If I say it in another way, why don't I create a decentralized application so that somehow I can communicate with my blockchain? And when I say blockchain, it means the smart contract deployed in the blockchain. So how this will happen? How this website and blockchain will interact with each other? Or I should say how this website is going to interact with the smart contract. So this thing is possible by using Web3.js. Now here, this Web3.js acts as an interface. Please do pay attention that this acts as an interface between the real world, here real world means the website or the application that you have created, and between your blockchain world, where you have deployed your smart contract on the blockchain. So here, if you want that your application or website should interact with the smart contract in your blockchain, then you will use web3.js. So basically, web3.js does this only. If we go back to the previous slide, here also the same thing is written. Here what it is saying is, it will connect you to the Ethereum node. So what does Ethereum node contain? Ethereum node basically contains blockchain only. All the process takes place in the Ethereum node, and the blockchain is also present in the Ethereum node. So web3.js helps us to interact with the Ethereum node, which indirectly means that we want to interact with the blockchain and the smart contract deployed in it. So this is made possible by web3.js. Now here it is clear in theory that web3.js helps us to connect our real world website to the blockchain or the smart contract that is deployed in the blockchain. But if we could have seen it in practical way, or we could have seen it with a bit of coding, then it would have been great. So let us go and check one of the examples. In this example, we will be using Truffle. If you remember when we have done this Truffle course, for reference, you can also check our Truffle course. There in that course, we have seen that we had React.js. We had a front end of React.js, which was communicating with our Solidity program. We had a Solidity contract that you can see here on this tab. We have this Solidity contract. And then here what we are doing is this app.js. This app.js is our front end, is interacting with our Solidity contract. So how are we able to do these things? So to understand these things, if you see closely, we were able to do all these things with the help of Web3. We have done this in Truffle, but what has Truffle basically used? It has used web3.js. If you see here, it has got imported, import get web3 dot get web3. Here this is our web3.js file, and here you can see that we have imported web3. So why did this get imported? If you see closely, in this contract we have two functions. First one is set and the other one is get. Now if we want to access this set and get from app.js, if you are finding it complicated, don't get worried. I am showing you this just for demonstration, and further in video all these things will get clear. So please don't get panicked that what is happening. First thing is, if you haven't seen that Truffle video, please go and watch it. You will get a lot of clarity from there. And further ahead we will talk about it. We will talk about its syntax and all in details. So don't be worried and just pay attention that the important thing here is that you are using web3.js, and this web3 is contacting your smart contract here. And where is it happening? That also I will show to you. So here we have two functions, set and get. And in this page, if I search set, then you can see what will happen. This first result is set state. And here you can see that this is our set function. If you see clearly, you will notice that I am calling this set function. Contract.method, these are part of web3 that we will talk about. And then set user value. So in this set, I am putting some user value. And where is it coming from? This is basically coming from our smart contract. And how is this taking place? This is taking place with the help of web3 module. All these things we will see now. If I talk about get, I will search get. And here you can see that we are calling get function also. Await contract methods dot get dot call. So this means the get function that is inside our demo.sol that we are able to call through app.js, and this calling we are doing with the help of web3. All these things are from our web3. If you haven't understood much here, don't be get worried. As we progress in the course, you will be able to understand all these things. Now the most important thing that you should understand about web3.js is that web3.js is nothing but a library which acts as an interface between your real world and between your blockchain world. And that is what web3.js is. Now we are going to see that how with the help of web3 we interact with our Ganache. So let us get started. So here what we are going to learn is, we will see that how to install our web3, how will we import web3, and how do we connect it to our Ganache. With that, all the accounts that we have in our Ganache, in Ganache multiple accounts are available. So let's say we want to know the balance of any particular account, then how we can know that with the help of web3.js. Next thing is the balance that we have fetched from the account of the Ganache, how to convert it into Ether with the help of web3. This is because the things that we get is generally in the form of Wei. So what we will do is, we will convert it in the form of Ether with the help of Web3.js. And after this, in the end, we will see that how from one account to another account. This means the accounts provided in the Ganache. So in those accounts, how we can transfer Ether from one account to another account. That also with the help of Web3.js. So after this, you will get a clear idea that what powers Web3 has and what can be performed using Web3. Like Web3 interacts with blockchain and Ganache is a type of local blockchain. So if you understand that how Web3 interacts with Ganache, then you will be able to understand that how Web3 will interact with any blockchain. So come, now let us go to our Visual Studio Code. So when we come to Visual Studio Code, the first thing that you will see is I have created a folder here. It is named Web1. You can also create a folder in your desktop or document. And after that, simply open the terminal here. For that, you can go to View, and from View, you can go to Terminal. You can also use the shortcut that is Control plus this symbol, that is single quote. So in this way, our terminal will get open. And now, as we have to work in our terminal only, I will increase its size so that you can also clearly see what I am doing. Okay, so here you can see that we are inside Web1 folder. Now the first thing that we need to do is we need to check whether we have Node.js installed in the system. This is a very important thing. So let us check it first. So yes, I have Node.js installed in my system and its version is 14. And if it is the latest version, then it will be better. Now after this, what we need to do is we need to install our Web3. But before that, we will use a command which we call as npm init -y. What will happen with this is we will get our package.json file, and here -y simply means yes, that it will say yes to all the content here. Now after this npm init -y, if you see closely here, you will find that inside Web1 we have got package.json file. Now in this package.json file, we have to bring our Web3. For that, what will we do is we will type npm install --save Web3. So this way it will come inside our package.json. It will get installed as well as it will get shown as a dependency in our package.json file that you will be able to see here. So the installation process is in progress. It may take some time, so we have to wait. If you see here, my web3.js has been perfectly installed. Version is 1.5.3 and the same thing is being shown in the dependencies of our package.json. I will close this one as I don't need it anymore and will bring it up. And now what will we do is we will run our node. So let me run our node terminal here. Okay, our node terminal is running. Here you can see I have typed node and now our node terminal is running. Now here I am just clearing my console. You don't have to do this step. This is not needed. I am just doing it to clear my console. I am just doing this so we can start fresh from the top. Now you can see like this. So till here we have seen that how to install Web3. Now we will see that how to import Web3 so that we can use it. So for that we will type here let Web3 is equal to require and then Web3 again. Here we are importing Web3 to this Web3. Now here one thing to keep in mind and notice is that I have kept this W as capital. You should also keep this as capital because this will represent our class. If you know JavaScript, then you will understand these things. For now, you can keep it in mind as a syntax that we are using let capital Web3. After this, I will press enter and now our Web3 is inside this Web3. I will simply write here Web3 and we can check this also. And here you can see that all these things are inside our Web3 now. I will once again do the clear screen so that we can get back to the top of the screen. For that, I will type console.clear. I am clearing the screen so that when I type, you can clearly see it. Now this thing that we did, where did it come from? It was coming from here. It was coming from our Web3. You can see this is our Web3. So now you know where it is coming from. In our capital W Web3, we have imported this Web3. And all of it is here only. I have just cleared the console. Please don't get confused that I have cleared all the content. I have just cleared the screen. The values of the package Web3 still remains in the capital W Web3. I will like to tell you again that I am here clearing the console so that you can clearly see that what I am typing in the screen. So after once again clearing the screen, what will we do is inside Web3, Please pay attention that I am using small web3 here. So here, now we will create an object. And how will we do that? We will do that by using the web3 class that we have created. And here inside this, we will type new capital web3. And then here, we will connect it to Ganesh. So here I will type providers.http. Here you can see it is giving suggestions. You simply have to follow the suggestions. If you do some mistakes, it can give a big error. And here inside this, what we will do is we will paste our URL of the Ganesh. For that, your Ganesh should be on. Here, the URL of our Ganesh. I will copy it from here. And here, coming back to this screen, I will paste it here. So this is done here. So now I will press enter. So after this, if you check in Web3, you can see we have got all the values here. Now we can control our Ganesh using Web3. If you watch carefully, you will see that what we have used HTTP. I think I have scrolled far too down. Okay, I will search Web3. That way we will find it faster. So if you see Web3, here we have got a lot of things. You can see here, we have got a lot of content inside this. How all of this is possible is because we have connected it to our Ganesh. And for that, what we have used HTTP. And you must also know this, that Web3 for connection with blockchain can use RPC. It can also use HTTP. It can use WebSocket. And one more thing that it can use is, it is IPC. It can also use IPC for connection. So by using all of this, what we are doing is, we are able to connect to our blockchain. Here, what is Ganesh? Ganesh is our local blockchain. And in a way, we have connected Web3 to this. And now we can control it using Web3, and we can also perform all the functions that we need to perform using Web3. I am again clearing the screen so that you can see what commands I am typing. Please remember, you don't have to do this step again and again. To clear the console, I will type here console.clear, and our console is clear now. We have got all the values in Web3. Now what will we do is, we will check that how we can check the balance of the account provided in the Ganesh. If you see here, you can see that a lot of accounts are given in Ganesh. Now let's say I want to check balance of any particular account. So now let us see that how we can do it. To fetch balance of an account from Ganesh, you have to type web3.eth. And when you see this, please don't get worried that how these commands are coming. I am not creating all these commands. All these commands are developed and tested, and I will tell you at the end of the lecture where you can find these commands. I will tell you that from where you can fetch all these commands and where it is provided. What is this .eth? All of this will get clear. For now, let us focus on the command that how we are going to get the balance of a Ganesh account. So here we will type get balance, and after that, whatever is the address of that account, that we have to type here. So let's say I want to fetch for this first one. I will copy this address from here and simply will paste it here. It looks like there is some error. Let me just check. I will repeat the same command. We'll paste the address again. I think I didn't close the double inverted commas. So here we have got get balance. So web3.eth.getBalance, and after that, whatever the address of that particular account is, you have to put that. Now if I terminate this command here, which means if I put semicolon here and close it, then you will see that it is returning promise. And therefore here we have to use .then, and then we will type console. And here all these concept of .then, promise, all these are part of advanced JavaScript. Therefore, if you remember, in the starting also I have told you that you should have some basic knowledge about the advanced JavaScripts if you are going to learn Web3 and similar concepts. If you haven't read about JavaScripts, then still you have time. You can go and check and learn about it so that you will get a clearer picture here. So here I will end the command, and that's it. So if you can see here, in terms of weight, we have got the value of ether. Here we have 100 ether, and value of this 100 ether in terms of weight is being shown here. Now let's say I want this in terms of ether value only. I don't want it in weight terms. So for that, what we will do is, we will use another command, and in that command, I just simply have to call the function. So here inside then, I will type function. It might be seeming a bit complicated for you, but you have to do this so that you can learn the process. Now a lot of you would be wondering that how I copied the same command that was in the above line. So let me tell you, for those who are using the terminal for the first time, here as I press the upper arrow key, it will give me the same command or the same line that was above. So here you can see if I keep pressing up and down arrows, we will find all the commands that we have already entered. You can also use this. So coming back to our command, here after dot then I will write function. Inside function, I will simply pass argument result, then again we will have bracket open, and here we will write console.log web3.utils. All of these are packages of web3 dot from way result ether, and then we will close the brackets. Please pay attention to close the brackets. Here I will close all the brackets that we have opened in the command, and after this I will press enter. And here you can see that we have got value of ether, that is 100. So the balance that was in this account has been provided to us in ether. Here I have done nothing much. If you see closely, I have just used the function result, and then I have passed the argument of console.log. After that I have used this package of web3.utils.fromWay to convert this in the form of ether. So this is what I have done here. Now let us see the other thing. That is, if I want to transfer some amount from one account to another account, let's say from this account to this account, then how can I do it? Let us see that also. Before moving ahead, I will clear the console once. All these commands that I am telling you or we are using here, I will provide a Microsoft Word file in the resource section. In that Word file, you will be able to find all the commands that we have used here. Now let us see that how we can transfer ether from one account to another account. For that, we will type web3.eth.send transaction, and after this, here we will simply write from. This means from where we want to transfer it. We have to provide that address here. So that address we can copy from here. You can see this is our address, and here we will paste it. And after this, we will write to. This will be the address where we want to send it. Again, we will go back and we'll copy the address to which we want to send it. Let's say this is the address. You can see both of these address have 100 ether each, and now we are going to transfer from first account to this account. We will paste the address here, and then let's say if we want the value in ether, for that we will write value web3.utils. This is also a package to weigh, and here in the bracket, let's say we want to transfer 5 ether. So here we will write 5 and then simply ether. And after this, let us close all the brackets. Please do check that all brackets are closed. After checking everything, we will press enter. So this is executed, and here we have transferred the ether. Let us check it once, and here you can see that we have successfully transferred 5 ether from this account to this account. In this way, what you can do is you can transfer ether from one account to another account. Now let us talk about what is the source for this. Let us see what is the source and how I am able to tell you about all these things, and from where you can explore more about it. So this is our source. From here I am telling you everything. If you will see, this is the complete documentation of our Web3. They have described everything in a very nice way, and I have used everything from here only. If you see, we have used web3.eth most of the times. So I will click on web3.eth. It is its package. The web3.eth package allows you to interact with an Ethereum blockchain and Ethereum smart contracts. We have already seen that how we interact with blockchain. We will also see that how to interact with the smart contracts. If we talk about functions, there are a lot of functions and you can apply different methods. You can do a lot of stuff. Like if you see here, there is a function called get account, and there are a lot more things that we will be using. That also we will see. You can also come to this website, and here you can see everything is provided, and you will get a lot of references of APIs. They have very nicely described everything here. Let me tell you that you don't have to memorize all these things. We will be using these things as and when required, like as we needed to transfer ether from one account to another account, therefore we used a function. Here we can see another package, web3.eth.contract. Here also you can see a lot of details is provided. These are related to contracts that we will see moving ahead in the course. So till now, let's see what we have done. We have seen installation of Web3, import of Web3, we connected with Ganache. We have also seen how to check balance, how to convert Wei into Ether, and how to transfer Ether from one account to another account. And now an important thing, for all the commands that I have used here, I have created a file. I have created a document with all the commands and that I will provide you in the resource section. You can find this file and you can use these commands as per your requirement. Further in the course, we will explore more things about Web3.js. This was just the beginning where we have seen that how Web3.js interacts with the blockchain. And now we are going to see that how we are going to interact with our smart contract using Web3.js. Let's get started. Let us first see that what we are going to learn in this part of the video. So here the first thing that we are going to learn is that how to connect your Remix IDE with Ganache, where will be our smart contract deployed. Our smart contract will be deployed in Ganache basically. So this will be the first thing that we will learn. Then in Remix IDE, we will write our code for our smart contract, and there we will see that how we will call the functions that we have written in our smart contract with the help of web3.js. If we are calling these functions, then how to set values for that function. Let's say I want to pass a parameter, then how to do that. That also we will see in this part of the video. So let us start and see that how web3.js interacts with our smart contract. So here we are on our Remix ID. Here I have created a small contract and have named it demo. Here I have simply created a variable x and have initialized it with 10. After that I have created a function set which is setting the value of this x variable. So whatever we pass here as an argument, so that value is going to be the value of this x. I hope you have understood till here. Now what will we do is we will deploy our smart contract in Ganache, and for that we have to connect our Remix ID with Ganache. We will go to deploy option, and here in the environment we will select the Web3 provider. And as I select the Web3 provider, it will ask me to which endpoint I want to connect. Web3 provider endpoint. So here I will put the URL of my Ganache. I will simply copy this from here and will paste it here in this box. Then we'll click on OK. And as I do this, you can see that our Ganache is connected to our Remix IDE. If you see, we can also see the network here 577, and all the accounts you see here are the accounts from the Ganache. As you can see, we have 034A, we have 0067. So here also we have 034A and 0067. Okay, so this is connected to our Ganache now. Now let us deploy this contract. So this way our contract is deployed to our Ganache. And here if I click on this, you can see we are getting a value that is 10. But now how we will be doing this? We will be doing this by using web3.js. For that, where we have to go? We have to go to our Visual Studio Code. So let us go to our Visual Studio Code. So here we are on our Visual Studio Code, and as you can see here, I am in the Web3 folder. Now here what will I do is I will run my node terminal. So now the node terminal is running, and here I will import my Web3 and then I will connect it to Ganache. For that, here I will type let web3. After this I will write require, then again web3, and in this way what we have done is we have imported it. Now after this, what will be our next step? The next step will be to create an object in Web3, and for that what will we do is new Web3, and inside this new Web3 dot providers dot http, and here we will paste the URL of our Ganache. So for that we will go back to this screen, we will copy it from here, and after this we will paste it here. So by this we will connect to our Ganache, and after this we will close the brackets and then we will press enter. So this is done. Now what will we do is we will create a variable named contract, and inside this we will put value new web3. Please pay attention that it is small w dot eth. This is the same package that we have earlier seen, dot contract we will keep two values. One value will be ABI of contract. This will be the contract where we basically want to point. So this will be the ABI of that contract plus the address of that contract. For that, where we have to go? We have to go to our remix ID and simply we will copy the ABI from here. Where can we find it? It will be provided in the compilation section. This is the ABI. I have copied it and simply I will paste it here. This will be a bit long. After this, here I will provide a comma. Please pay attention that I have provided a comma here, and after this we will provide the address of the contract. So let us get back to the previous screen, and here we have the address of the contract. I will copy this and we'll go back to our Visual Studio Code, and inside double quotes we have to provide our address of the contract. So paste it here and our work here is done. Now I will close the bracket, will provide the semicolon and will press the enter. So this way we have completed this task also. Now basically inside this contract, it is pointing onto this contract whose ABI and address we have provided here. So again we are on the bottom of the screen. So I will clear the console so that you can clearly see what I am typing in the commands. You don't have to do this. So our screen is clear now. Now in our contract, the contract is pointing towards the contract whose ABI and address we have provided. Now through that only we will be calling the methods of that contract. For that we will use its methods. So we will write contract dot methods dot, and here we will give the name of the function. Now here what will be the name of the function? If you see closely, the name of the function will be x. Why is it like that? Because in Solidity, any of the variable, like here it is x, so any variable that is a state variable and which you have kept public, so for that it will automatically make a getter function. For that variable we don't have to create a getter function. That is why I can directly call it here. I will write x function call dot call. Through this I will be calling it. Now if I press enter here, it will give promise as a result. So we have to resolve that, and for that we have to use dot then console.log and then finally enter. Here you can see the value that we have got is 10. Now if you go back to your remix ID, here you can see we have initialized it with 10. So what we have got in return here? We have got 10 as return. So by this now we know that it is working completely. So through web3.js we have seen the first thing, that how a function is called, and you can see it's a very simple method. Just type contract.methods dot the function that you want to call and then dot call. Now this command returns us a promise. To resolve that we use then console.log. Now let us see the second method by which we will set a value in this. Now what will we do is we will call this function set, and here the value of x we will pass as an argument, and then we will check if there is any change in value of x. So let us go back, and here I will press Ctrl C so that I can come out of it. After this what we will do is we will type contract dot methods. Here we are going to call a function, and this time we will name the function as set, and in set I will put a value. Suppose I am putting it as 90 here. You can put any value that you want to pass. After this pay attention that I am writing send here, and in send I have to tell from, and here in this from we have to tell that from which account we want to send the value. As you know, we have lot of accounts here, so we have to specify from which account we want to do this process. This is because when we set we have to pay the gas fee. So because of that I will copy it from here. Here I will be selecting the first account. It's up to you that which account you want to select. Inside double quotes paste the value and then simply close the brackets. Finally press enter, and you can see our work is perfectly done. Now let us see if our function has worked or not. For that we will again use contract.methods and we will call x function, and then let us see what value we get. You can see we are getting 90 value on our screen. How 90 is coming here? Because we have set this value. Set was our function. Now if you see closely, here set is our function. This same function we have called, and inside this we have put value as 90, and this 90 is value of our x now. There we got the value 90. Now let us check in our remix ID. So I will call x, and here you can see that it is 90 here also. So our function is working perfectly. You can see 90 is getting shown here. So by using web3.js you can simply call function as I have done here. You can set the value of the function. So the same thing or the similar pattern that I have done here, you have to do in frontend also. So when you add frontend in your application, you have to use web3.js like this. You can see it's a very simple process. It is not as complicated as people say it is. These are very simple functions. The only thing is that you should know how to use them. So here we have seen everything, that how to connect your remix ID to Ganache, how do we call a function, and how do we set a value in a function with the help of web3.js. And now we are going to see that how our browser interacts with our smart contract with the help of web3.js. So let us get started. So here we are on our Visual Studio Code, and now what we have to do is we have to connect our Chrome browser to our blockchain, which means we have to interact our browser to our smart contract. So what will be the first step for this? I have created this web1 folder earlier. First of all, we have to create one HTML file. And now we want this index.html should interact with our smart contract. For that, first of all, we have to install a package. The name of that package is web3.js.browser. With the help of this package, basically what we can do is we can interact with our blockchain. Here when I say we, I mean our browser can interact with our blockchain. Installation is in progress. We have to wait a bit. As soon as it gets installed, we will connect our Chrome browser to the blockchain. It is going to be very interesting. So let us wait for the installation to complete. Okay, so here our installation is complete. I hope you have also installed it along with me. To use this package in our HTML panel, we have to import it. So what will I do here is, I will simply import it with the help of script. This is because this will be a JavaScript file which we will be importing. Here we have to write script source. In the source, we have to provide the location of the package that we have installed, location of the file that we want to use here. That information we have to provide here. Here I will type browser, and inside this folder, actually you must be thinking that how I remember this address, but it is because I have used it quite a number of times. You don't have to remember this. I will simply share the link in the resource section. You can directly copy it from there. Here I will write script, and we are done. I think I have done some mistake. We'll correct it here. Okay, so done now. Now here what we are doing is we are importing our web3.js from node module, web3.js browser, build, and then web3.js. I will save this now, and now let us go to our index.html. So here I am on my web1 folder. I will simply click here on index.html. If you are not getting this Chrome icon, you can right click on this, and then in open with you can open using Chrome. For me, Chrome is default, so I can open it directly from here. Double click, and here our index.html is opened. Now we will open our console using Ctrl Shift J. So to open your console, you have to press Ctrl plus Shift plus J. Now what will we do here is we will use our Web3 to interact with our smart contract. Now let us check if our package has been properly imported to our HTML. For that, here we will type Web3 where W will be in capitals. Press enter, and here you can see that this thing is working completely fine here. Now here we don't need to import anything. Like previously we have seen that we imported capital W Web3 using require. Here we don't need to do all that things. Here we can directly create an object for Web3. So here I will type let Web3 with small w. I will increase the font so you can clearly see what I am typing in commands. I hope you can see this now clearly. One more thing I will do is I will clear the screen so you can see it clearly. So here I have typed let web3, and simply the commands that we have already used, we will be using them here also. So I will type new and web3. Now here what will we do is we will connect to our Ganache. New.web3.provider. I hope you remember what we are doing now. After this .http provider, and inside this we will provide the link of our Ganache. So let us go to get the Ganache link. Here this is our Ganache link. I will copy it from here, and then here I will paste it. Simply I will close the brackets and then finally enter, and wonderful. Now let us try to use some of the functions if they are working properly or not. For that, here I will write Web3. Now what will I do is I will try to access the accounts in the Ganache. So for that, web3.eth.getAccounts. Here it also provides us suggestions. If you see here, as this is giving a suggestion, I will try to use them and then I will press enter, and here it is. All the accounts that were in the Ganache, I will open the Ganache account. So here you can see that all the accounts available in the Ganache are shown here also. Now why is this so interesting? I have connected our browser to our blockchain. We have connected it to our Ganache, and what is Ganache? Ganache is our local blockchain. And now you can see that our browser can directly interact with our local blockchain. What is the good thing about it? So the good thing about it is, think if you are going to create your browser as your front end, so your front end will directly interact with your blockchain. So how all this is happening behind the scene? It is happening through Web3. Earlier we had MetaMask. I will show you the MetaMask wallet. So this also used Web3 for connecting to the blockchain. If you open any page on your browser and you had MetaMask installed in it, then what MetaMask used to do is, it used to inject Web3 object on your browser and then it used to connect it to your blockchain. And this would happen whenever your page will get reloaded. But for security reasons, now MetaMask do not use our Web3, which means it does not inject your Web3 object on the browser. But earlier, MetaMask used to use your Web3 object or Web3 for connection to blockchain. Now if you try this, let's say open a random page on your browser and then log into your MetaMask wallet, and simply if you have your MetaMask installed on your browser, and now if you try to use any object of Web3, let's say by writing a method, I will use this method written here, web3.eth.getAccounts. When I press enter, you can see that it is giving us a warning that MetaMask no longer injects Web3, but earlier MetaMask used to use your Web3. If I click here, a new page will open, and you can also follow this link. I will share this link in the resource section. You can also read it from there. Now if you see, Ethereum is being used. Earlier MetaMask was used. Since we removed our windows.web3, MetaMask no longer automatically reloads the page on chain or network changes. So this has been mainly done due to security reasons. Now here what they are using is Ethereum. So this is the exciting part of this, that how all of this works, how your browser works behind the scene so that it can connect to your blockchain. So knowing all this is very interesting, and I was very excited to know all these things. Now here, any type of function that we have used or any method that we have used, like we interacted with our smart contract using node.js, you can try all of that and it will also work perfectly here. Now all the methods where we have created the instances of contract, new web3.eth.contract, and we entered ABI and contract address there. All these things you can do here as we have done in our node.js. I am not doing all these steps again. As you can already see that we can use Web3. We can use methods of Web3. Similarly, you can create instances of your contract and you can interact with your contract. If you have created your smart contract in Remix ID, you can easily interact with your smart contract. With the help of Web3 and with the help of your browser, you can do this. So this will be your task. I am giving you this task and I hope that you will complete this task as it will help in learning. By doing this, you will have an idea that whatever you have learned, you can apply it practically also. You can create instance of your contract here like we have done previously also. Let contract. I will just show you that what you have to do. Simply create the instance of your contract, new web3.eth.contract, and after this what you have to do is simply provide ABI of your contract here and mention your contract address here. The same thing we have already done previously also, where we have done this in node.js. Definitely we haven't used it in Chrome, but the process is same and I don't think we have to repeat it again. And after this what you have to do is call your function as we have done previously also. Let me also show that to you. So previously in the video we have created this contract, but what we had done is we have simply gone here. We connected our Ganache from here by going in Web3 provider. Here you have to provide your Ganache link in the Web3 provider, and simply by deploying your contract, what you need to do? Okay, I will give you a small recap if you have forgotten the things. I am doing this so that you can do the task because it is very important and it will be good for you. You just simply have to paste it here. I think it didn't get copied, so I will copy it again. and then we'll paste it here. Simply click on OK. Now where is your contract going to deploy? As you click on deploy, it will get deployed on your Ganesh. If you click here on the drop down, you can see all the accounts of Ganesh are here. Now you have to simply use the AIB that will be provided here in this compile section, and then you have to take this contract address, and where you have to paste it, that you have to paste it in your browser, that is here. And then like we have done previously, we have to call the function, and then we have to pass the value for the smart contract function that we have created. And now we are going to see that how an ABI and bytecode is generated for a smart contract with the help of web3.js. So let us start. So what is so special here? We have already generated ABI and bytecode in our remix IDs. When we have used truffle, there also we have created it. Then why is it so special? If we create it in web3.js, we can anyways get ABI and bytecode. So today what we will get basically to know is behind the scene how your remix ID or your truffle ID actually works to generate your bytecode and your ABI. Till now what we have seen is only surface level, like remix ID generate ABI and bytecode for us, truffle generates ABI and bytecode for us, but we never did it ourselves, right? Today we will see that how we can create ABI and bytecode with our own capabilities by our own programming. So now let us start. First of all, let me tell you that what I have done here. I have this demo.sol here. This file we have created earlier that we have used in our remix ID also. We have used it in our web3.js course. So I have created a file named demo.sol here. I have created a new folder with the name webnew, and inside this I have created two files. First one is demo.sol. In this we have our Solidity code here, which we have been using in our web3.js course. And here this one is webnew.js, and here we will code our web3. So this is what I have done till here. So now let us start coding. Now what we have to do is basically we have to generate ABI and bytecode. So what should be the first question? That what we need to generate ABI and bytecode. The first thing that we need to generate ABI and bytecode is Sol-C compiler, because it is the Sol-C compiler that actually compiles our smart contract, that is the smart contract in the Solidity. So here the first thing that we are going to write is Sol-C is equal to require. We haven't installed Sol-C yet, that we will do later. For now we are writing the codes. As we haven't got it by default, that is why we have to install it. So this we have written here, and don't be worried, I will give you everything in a written format in details, that what is used for what purpose. So don't get worried. I will provide everything in details in our resource section. So here what we have done is we have required our Sol-C compiler, which means in a way we have imported our Sol-C compiler. From where we have imported it, that we will see when we will install it. Now after this what we have to do, suppose we have installed our Sol-C compiler. Now what we will do is basically we will compile our code, but for compiling the code what we need is we need a method by which we can read our code, because in demo.sol our file is written and we want to compile it in webnew.js. So in some way we have to read our demo.sol file, and for this purpose we will require our fs. And if you haven't heard about fs, we are talking about JavaScript here. So this is like a package of JavaScript. By using this JavaScript we can read and write files. So I am using that JavaScript here. But if you are not understanding it or it is not clear, please don't get worried. Just see how this complete process works. Later you can read about JavaScripts and come again, and then you will be able to understand clearly what is happening here. I will be covering all the steps here. Most of the things you will understand. And now here I will write fs. So our first step is complete. We have taken a compiler. Our second step is also complete, that how to read our file. Now what will be the third step? As we have compiled our file, we have read our file, and now we will deploy it also. Where we will deploy it? We will deploy it in our Ganesh. And now if we need Ganesh, what we have to use? We have to use our Web3, because without Web3 we cannot connect to Ganesh. We have already seen this in our course till now. So here I will write require and then Web3. All these things we have already discussed. Now here what we will do is let Web3 is equal to new Web3, then again new Web3, where W is capital, dot providers dot HTTP provider, and here we will put the URL of the Ganache. For that, let me open the Ganache first, and from here I will copy the URL and here I will paste it. So here the setup we needed for deployment, that is also over here. So now we have completed three things here. If you see, first we have required this package. After that we will install the package, and here at the last what we have done is to connect with our Ganache we have written this last line. So with this what we can do is we can connect with our Ganache. Now in next step what we will do is, now in the next step we will read the content of our file, that is demo.sol. For that I will create a variable file content, and by using fs that we have already required or imported, read file sync, and here inside this I will keep my demo.sol, and then I will convert it to string. This is because if we don't convert it to string, JavaScript will give it to us in different formats, which we may not be able to read also. That is why I have converted into string format. Now what will we do is, we will get it printed to see if our content is proper or not. For that, I will write console.log file content. So by doing this, we can print our file on the screen and see if our file is proper or not. Now, in the next step, what we will do is, we will put an input to our Solidity compiler. This is because without giving input to Solidity compiler, how it is going to give us an output? So we have to give an input to our compiler, and the format for that input is something like this. So this is our input format. I will reduce its size a bit. So this is the input format for our Solidity compiler, or we can say for the Sol-C compiler, it is the input format. We cannot give file directly to our Sol-C compiler. Like here we have a file and we can give it directly to Sol-C compiler. That is not possible. It has a structure and format. So this is the format in which we will give input to Sol-C compiler. If you want to check, this thing is given in Solidity document, but obviously here I have done certain refinements because in Solidity document a lot of things are provided. So I have copied and pasted the code here. This is a big code, a bit messy. So if I would have started doing this, it would have taken a lot of time. So you don't have to worry about all this. I will provide it in a file in our resource section. You can simply copy it from there and you can use it. Here you can see everything is provided, like our file name demo.sol. Then we have file content. So from here I am giving this file content to my Sol-C compiler. Okay. So now let us go to our next step. What will be our next step? Now we have given our input to the Solidity compiler. Now this compiler will give us an output. When we will give an input to this, obviously it will give us an output. Whatever output we get, we have to convert it into JSON format. Why is it like that? If you have worked in Truffle, you might know, or if you have seen my Solidity course, there you would have seen that whenever we compile any file, that gives an output in a form of JSON file. And then we fetch ABI and bytecode from that JSON format file that it has provided us. So basically whatever input we have provided and whatever input that we are going to get, we have to convert it into JSON format file. For that also we will be using JavaScript only. For that, here I will type var output. If you haven't understood anything, it will get clear in a while. Here I will type json.parse solc.compile. So if you look carefully, what I have done here is I have compiled solc json stringify. Actually, I am giving an input to my solc compiler. So the input that I gave there, that I am giving in this solc compiler, and this solc compiler will give us an output. That output we are converting in format of JSON. From this JSON format, we will fetch our ABI and bytecode. I will show it to you. Here, this is our input, and we have given it to our solc compiler so that it can provide us an output, and that output we are converting to JSON. Now by using this output, what we will do is we will generate our ABI and bytecode. I will do one thing. I will print the output also so that you can also see it. From this output, we will fetch our ABI and bytecode. And for that, we have to write here output dot contracts, and you will come to understand about this when we will get it printed. Then demo dot solve, and here again we will write demo. What is this? You will understand now. Dot ABI. In the same way, I will take bytecode here. Bytecode is equal to output dot contracts, again demo dot solve, and then again we will write demo dot evm dot bytecode dot object, and bytecode also we will console dot log ABI. Here I will provide a colon, and here what we will do is we will console our ABI, and in the same way we will write console dot log bytecode, and here also we will print our bytecode. So here our work is over. Here I will provide a semicolon at the end, and here on bytecode I will provide a colon. So our work is done here. We have generated ABI and bytecode. So let us recap till here that what we have done. First we have fetched the compiler, then we have fetched FS, then we have fetched Web3, and then we have connected it. Here we have simply tried to read our demo.sol. After that we are trying to print it here, and then the file content in the demo.sol we have sent it as an input to our solc compiler. And at the end what we are doing here is the output we get from solc compiler using solc.compile, that we are converting to JSON format, and through that what we are doing is actually we are generating our ABI and bytecode. Okay, now I will save this, and after this we have to install our packages. Here I will write npm install. Here we want solc, fs and web3, and as I press enter it will get installed. It will take some time. Okay, so one thing that I want to tell you is when I was trying to install it together, it has given me a lot of errors. So if you are facing the same problem, you can also do it individually. Generally these problems should not come, but as I faced this problem, I got so many errors while installing them. So I thought I should tell you that I have installed it individually, and now it is working perfectly. So here, first of all, I have installed Web3 here. So you can also do it individually. Like here I have done for solc, and then finally if we scroll down, here I have installed fs. So while installing, if all three of them were installed together, then it is very good. If you are also facing these errors, then try installing them individually, like npm install fs, npm install web3, and npm install solc. So here this thing is complete now. Here we have to write node and then web underscore new dot js, and as I press enter, our program will get executed. I think I have done some mistake here, so it is telling me that it is saying read file sync is not a function. Okay, I think here I have made the mistake. I have kept capital C in the syntax. That is why we are getting this error. So I will correct it. Let me find it. So I will correct it here. I will save it again. You may also face these kind of problems. While executing big programs, we may face some errors. So let us execute it again and see. So it is working. Let us see what output we have got from this. So the first thing that we wanted as an output was file content, to check whether our file content is proper or not. So here you can see our file content, contract demo, uint public. This is simply a JavaScript format. So if you are having difficulty in understanding this, you have to refer JavaScript. Now after this, the second thing that we wanted as output, that was this output. That is whatever the output that we are getting in JSON format. So let us check that also. So here it is. You can see here contracts demo.sol demo.sol id is equal to 0. Now after this, what we wanted to do is we wanted to print our ABI, and if you see here, you can see that ABI of our code is here. I will increase its size a bit so you can see properly. Here you can see the ABI input. ABI we have already studied. If you haven't seen my Solidity course, please go and check it. I have explained everything in detail there. Here ABI is the name of our function. If you go to demo.sol, you can see that it was set, and in our ABI also it is showing. And here this is our bytecode that we have perfectly and properly generated. And one more thing I want to show you that I have already told you here. I have written demo.sol demo. So where it came from? It came from here, that is contracts. Contracts demo.sol demo. I have fetched it from here and then used .abi, .evm, .bytecode, .object. I have used here also. I hope you have understood how this program is done. I will provide a file in the resource section. You can check that file from there. You can also test it. So we have done everything till here. Till here we have simply seen that how ABI and bytecode is generated. But moving ahead, we will see that how to deploy it with the help of web3.js. So let us go to our VS Code. In the last section, we have seen that how to compile our contract with the help of web3.js. There we have written some code like this. I hope you remember these things. I have also shared the file in the resource section. You can go and check it out there. So what we have done here is we have mainly compiled our contract, and through that we have generated our ABI and bytecode. But here what we are going to see is how to deploy our compiled file. This file we are going to compile again, and then we will see how to deploy it on our Ganache, that is our local blockchain. So the first thing that we have to do is we have to create instance of our contract. For that, here I will write contract. After that, new. All these things we have already done when we started Web3 course. Here it will be web3.eth.contract, and inside this we will pass our ABI. We have already generated ABI above, so we will simply pass it here. Now what will happen through this is our contract variable will point towards the instance of this contract. So here we have done this so that we can point on the contract and finally we can work on it. Now next what we can do is we can use Web3 and we can get the print of the Ganache accounts. Web3.eth.accounts. Why am I doing this? That you will understand. After this I will write dot then. All these things that I am writing here are part of JavaScript. I should say JS6. I am using that syntax, and if you are not getting it, please don't get worried. It is more important to understand that what I am doing. You don't have to by heart these codes. Simply I will provide you a link in the resource section, and whenever you want to use it, you can go there, you can copy paste it and you can write it. Don't need to remember it, but it is important to understand that how it is working. But it is important to study JS6 if you want to work in Web3. After writing the code, in the end we will provide curly braces. Now what will we do? Now all the accounts that we have in Ganache, we will get it printed to check if it has got connected to our Ganache. Here I will write accounts, and here only we will get the print for the accounts that we have taken in the above line. And then I will close this command with semicolon. So let us run and see if it is properly connected to our Ganache. I will save it and then I will open my Ganache. So here you can see my Ganache is open, and what I will do now is I will print all these addresses on my console. Let's see if it is working or not. I will open my terminal. Here simply we have to write node, and then we just have to write the name of our web_new.js. I will press enter and let us see if it is properly working or not. I think I have done some mistake. Let me check that. What mistake I have done? Okay, I think I have forgot to enter get here. That is why it is very important to check your codes, because sometimes these codes are very lengthy and there is possibility of error. I will run it again and let's hope that it will work. Okay, so you can see that our contract is working perfectly here. All the accounts of Ganache are showing here. You can check from this Ganache screen that all the accounts that are in Ganache are displayed here on my console. This means that our Web3 code is working perfectly. Now what will we do is we will take any one account, that is one account from this Ganesh through which we want to deploy our contract. This thing we have already seen in our remix ID, that when we wanted to deploy any contract, we had to select an account. This is because whichever account we use to deploy the contract, that account has to pay some gas fees. Therefore, we have to select a particular account. So now I will select one account from the Ganesh. Now what we have seen on the screen on our console was list of an array, or you can say it was list of element in an array. From that, let us fetch one account. Here I will write account 0. I am fetching the account with index 0. I will also declare default account. So with this, we will get a default account with the index 0, that is this account. Its address will come to our default account. And with the help of this account, we are going to deploy our contract. Now let us go to the next step. If you want, we can print this default account also. For that, console.log and then default account. By this, you can also check which is your default account. Here again, we have to write default account. So this step also is done. Now what we can do is we can finally deploy our contract. Now the instance of the contract that we have created, we will use that contract dot. Now what we want to do with this contract, we want to deploy it. So I will write deploy here. After this, I would say this code is going to get a bit messy. This is because I am going to use a lot of syntax from JS6. We will use dot then, dot send. Few of these things are from Web3 also, but codes will get a bit complex. So don't get worried. Don't leave it halfway. I will try to explain each and everything step by step so that it is clear to you. Please do pay attention as we are going to go deeper into this. So let us start. Here I will type data, and inside this I will put my bytecode. This is because we need our bytecode for deploying the contract. That is why I have used it here. Now after this, I am going to deploy the contract, but for deployment I need a particular address through which I am going to deploy this contract. So here inside send, I will use from, and the value that we have taken in the default account, using that value or that address, I will deploy this contract. We also need to pay the gas fees, so I will type gas here. Here you can use any random number. Let's say I am using 50,000. Suppose after deployment, if you see a gas failure error, then you can increase this amount. For now, I have taken it as 50,000 and I think it is more than enough. Or let us keep it 5 lakhs for the safer side. Okay, now what we will do is, this is a very important step, so please pay attention. As we are going to deploy the contract using the bytecode and the default account, so what will happen is, as we deploy the contract, blockchain will return certain values like events, transactions, address of the contract, etc. As we have deployed it, so for the reference, blockchain will return certain values. Now these values we have to hold, or I should say we have to obtain or catch from the blockchain. So for that, what we basically want to use is dot on. I will save this file and I will align it properly. Here I will type dot on receipt. I will explain this to you. First I am just typing the code. So receipt and receipt again. And now here I will simply close this. Now through this receipt, what we want to do is we want to access the address of the contract. So we will be accessing it using this receipt. How to do that? I will show it to you. For that I will write console.log contract address, and here what will I do is I will write receipt. I would like to tell you that all these information we are getting from blockchain, we are only going to use them. And here I will write contract address, and through this what will happen is we will get the address of the contract very easily. Okay, I think everything till here is clear now, and I will close this here now. Please do check the number of brackets that you have opened. You have to close them also. Like here, I have closed more brackets than I have opened. So through this line, you will be able to understand that what I am doing, I am trying to refer the address of the contract. This means the address given by the blockchain, we are trying to grab it. and then we are trying to print it on our console. So this thing we have done in our first step. Now in the second step, what we will do is, in the second step also, we will take a new variable, demo contract. You can take any variable. Here I am just taking demo contract. This will also be provided by the blockchain, and through this what we will do is, in our contract, like demo.solve, this is our contract. Inside this, let's say this function I want to call, so we can do it from here. For doing that, I will simply write here demo contract dot methods, and then what will I do is, I will call my function, that is x function dot call, and inside this I will put all these syntax. This syntax is from JavaScript. Here I am using the callback function, which is part of JavaScript, and here I will type console.log, and here what will I do is, I will print the value that is given by the blockchain when we call the function or when we call the contract. We have done this calling by this line, demo contract dot methods dot x dot call. Whatever value it will return, we will print that here. So here I am writing initial value. I know this will be looking a bit complicated, but if you remember, I have already told you that some parts will look messy, like here callback function is used, some JavaScript is used. So please don't get worried. After this, what we have to do, we have to simply print the data. So here our data will get printed. Now I will save this file. I hope I haven't done any mistake. So here we have done a very simple thing. I know by looking at it, it looks a bit complicated because the structure is difficult. So let me explain once more that what has happened here. Here we have deployed our contract using the instance that we have created here. You can see here we have deployed it. In the next line, we have used the default account which we have initialized here, which actually is this address of the Ganesh. Through this, what we have done, we have deployed our contract. Now if we come to the next line, dot on I have provided because blockchain will return some values like contract address, transaction details. All these things are provided by blockchain. With dot on, in a way we are handling that data. We are telling blockchain that whatever data you are providing, you can provide it in receipt, and from receipt, by using the method, we will access it. And after that, what we have done is, with demo contract, we have called our method. This syntax you might have seen before, where we initially create contract instance and then call method.x, or whatever the name of the function is, we used to call it. All these things we have done, and the same syntax we have used here also. And here, whatever result it is providing, it is getting saved here in this data. Here we have used the callback function, and that value of the data we will show here. So this is what is happening here. And now let us check the compilation also, if it is working fine or if there is any error. Let us run it once, so we are assured that it is working. So here I am going to run it once. It is working. If you see here, it has given us the default account value. If you want to check it, this is the same. After this, it has told us what is the contract address. This is the address of the contract that we have deployed. With that, when we called the function x, it has returned us the value 10, which was the value of x in function. And if I had to show you here, if we go here, you can see value of x here is function. The same value has been returned here. So in this way, using web3.js, you can deploy your contract. But here there is an important thing that you should know. With introduction of Truffle, we don't need to do all these things. Truffle has made our work a bit more easier. You don't need to do the hard coding in web3.js, but still sometimes we have to do a project that we have to start from the scratch. Then you will come to this type of format. But here also, as I have told you, you can simply copy paste the format. This is a working code, and the only thing that you have to remember is that when you call the function, then you have to make few changes here. Otherwise, this is a completely working code. So copy it, paste it, and run it. I would like to reiterate that you do not have to remember these codes. Simply as a format or as a structure, you have to keep it with you. So whenever you need it, you can simply copy paste it and run it. Let us summarize once that what we have learned in this course. The first thing that we learned is web3.js. What is web3.js that we have seen? We have talked about its modules. After that, we have seen that how web3.js interacts with Chrome. We have seen that how using Chrome we can access our blockchain. How to generate ABI and bytecode, that also we have seen. And finally, how compilation and deployment of our smart contract is done. that also we have seen. So here finally we have successfully completed our web3.js course. Congratulations on completing this course successfully. I hope you have understood the things and whatever you have learned will be useful in your future projects. Thank you.